introduction, and thanks for the invitation to this very important and August gathering. Just to talk a little bit more about who I am and what I do. As Thomas mentioned, I'm one of the managing directors within Accenture's Applied Intelligence practice. Accenture's Applied Intelligence practice is about $6 billion globally, which is analytics plus artificial intelligence, deploying that on Fortune 500 companies and many more. In my current role, I primarily serve clients in the banking, capital market and insurance space, and I work across a range of problems which can be solved using data, machine learning and AI. In my prior role, I had set up multi-country data science teams in Argentina, Poland, China and India, serving our clients in different geographies all over the world. So I'm very excited and passionate about this topic. I'll probably start off with something which actually I observed about a year and a half back. NASA actually published a news saying that machine learning is actually help them discover a new planet. We talked about machine learning doing recommendations on Amazon, right? If you buy product A, it recommends product B. That's machine learning driven. But what about discovering a planet using data and machine learning? And I'll just play a small video. Essentially, what it does is NASA captures, its Kepler telescope captures the light at every moment, which is emanating from different stars, and as planets pass by these stars, there is a dimming of the light. Earlier, all that data was being captured and it was visually analyzed for them to really figure out if it's a planet. Now you have a machine learning algorithm that really sits on top of that data and crawls through all that data and really detects if a dimming of light means it's a planet which is passing by. That means that we're going to see multiplication in the number of new planets which are going to be discovered using machine learning. Just one of the several examples. Let's just start by how we define machine learning. Machine learning is almost like, sorry, not machine learning, I'll say how I define artificial intelligence. artificial intelligence is like a discipline, physics, and it has, that discipline has different components. Machine learning is a sub-component of AI. For simplicity, we say it's a combination of 4 different things. One, which is sense. Machine will sense, then comprehend, make sense out of what you sense, all the information that you gather, act, and then learn. Essentially what it does, it learns from all the data that is generated. For each of these 4 dimensions, if you see, from a sense standpoint, computer vision, essentially what it does, any photograph or any picture that you take, is computer vision is a technology that categorizes those pictures. Natural language processing is one example of comprehension. Essentially, if you have got very complex reports, detailed financial reports or commentaries, natural language processing, essentially it comprehends that report and it extracts sentiments and entities out of that. Learning is where once you sense and comprehend, then you deploy your different machine learning technologies. As I mentioned, deep learning or reinforcement learning, something that Spencer is going to talk about. And essentially, when you really go and act, and that's where your bots come into picture. All the intelligence that you have gathered through sensing and learning is deployed using a conversational intelligence. Essentially, when you go and ask a query, on regarding some question that you may have with a financial services firm, that query is responded by a bot. And bot is nothing but an intelligent conversational agent. So all this is brought together as part of the AI capability. As we talk about what AI can accomplish, I think there are some 6 or 7 big things that are happening in this space. First of all, this is all open source. Earlier, you went to a company like SAS to go and analyze your data, and you pay a lot of premium for using their tools. Now, a lot of these AI and machine learning tools are available. They are open source. You can go and pick libraries of different providers, and you can just start download and start using it. It's kind of revolutionized the way communities are coming together and developing new codes which are democratized. The student community is one of the biggest beneficiaries of this, because they can get the best codes or best algorithms that they can download and start using. The second one is what we call anywhere, anytime data, which is APIs. Earlier you had to have data and algorithm and everything put together in one place, in one server. Right now, when you go on Netflix and you ask for a movie, that movie is not sitting there. That app goes and calls an API and brings you that movie on your screen. So that's the kind of power of API. Now, APIs are really, in our day-to-day life, we don't even realize how many APIs we touch every day. Almost near unlimited computing power. And the cost of computing has really gone down. So, if you were spending like $100, 10 years back, now probably you're spending a cent for the same computing cost. So pretty much it's almost, computing cost has plummeted. Amazon, Google, Microsoft Azure provide some of that, free of cost for your proof of concepts or for experiments. And the one that I really feel is that this explosion of dark data. All of us leave a lot of footprint, right? When we go online, or when we go and tweet, or when we go and order, a coffee in Starbucks, when we swipe our cards, we leave a lot of digital and non-digital trail of information, and all that information is what I call the dark data, which is not really residing in a particular system, but it's available everywhere, and it's a question how much you can mine that data to drive intelligence. The next one is really the productization. This is where startups, fintechs are coming together, and they are bringing capabilities which are truly remarkable, right? They are bringing industry knowledge, software, and data, and building new solutions. And finally, AI-powered experiences, right? So a lot of time when we go and do a chat, when we want to change our telephone numbers, we don't interact with a human being, and our request is kind of completely serviced through online digital assistant. And finally, the ethical AI, because this also comes with AI bringing a lot of biases and decisions which are mechanical, and how do you really take care of them? So these are 7 big themes that we see, and we've kind of published it in our annual thought paper. This one actually I mentioned a little bit in terms of the the information that we are really leaving. If you see the number, pretty much, and this is one of the capabilities that Accenture has built. That's why I particularly brought this example. Whatever, when you carry your phone with you and you've got 20 different apps, all that digital trail is left. And then, when we give our consent to use that information, all that information can be utilized for, better customer service. Similarly, when we go and really, do an online search about a product or a service, all that information is captured and can be utilized for, again, better customer service or better product targeting. But I think the key point here is, I think there's only, I would say, 5 to 10% of that data is being used today. 90% of that data is not being used, and that is what we call dark data, and that is what you can start using big data and machine learning capabilities. This is where I talked about creating analytic products or creating AI-driven products. You can see that on the chart on the left, there is a massive investment in AI-driven fintechs. It is kind of skyrocketing. This number is a little dated. We have data from 2017, and what it is leading is a sample of products on the right. There is a product for fraud detection. There is a product for underwriting. This is an example from a bank. Wide variety of AI analytics and data-driven products which are coming to play, and they solve your most complex business problems. This one I'm kind of particularly it's very interesting to talk about. This is an example with one of the telecom providers. When you go and ask for a particular service, if you want to go and change your phone number, earlier what used to happen is when you go and put that query, when you call a call center, and there'll be a representative who'll come online and he'll answer your query and ask, okay, so you want to change your phone number, what phone numbers you like, so on and so forth. Now there is, with the availability of Amazon Connect or Google Dialogflow, these are all conversational artificial intelligence capabilities. You can divert your calls, manual calls, through digital assistant and follow the instructions, and your phone number will be changed. We observed that it did not reduce the customer satisfaction, so it did it very effectively, almost replacing a human being on the other side of the phone. So these are the kind of capabilities which are really coming together to form what I call the what we call as this coming of age of AI, right, to solve our day-to-day problems. Just from so that's kind of some of the broad trends which we see, and it has applicability across wide variety of business functions and industries. From a finance transformation perspective, because this is a audience which is finance and obviously much more literate about finance function than I am, but in working with my colleagues in that space, we figured that there are 3 new what we call the next wave in terms of finance transformation. The first one is eliminating the manual intervention. Whatever task which required manual intervention, whether it's really manual processing, reconciliation, some of the data integrity and quality issues, and so on and so forth. Efficiency is being driven through machine learning and AI analytics. The second one is real-time decision making, where your algorithms can predict things that you cannot so easily do, or it's going to take a lot of time. So the performance or the feature prediction is driven by AI and machine learning. And finally, what impact it has on the talent. We saw amazing talent in this room who are being recognized for the great work they did. I think it's also about reorienting some of that talent to be machine learning and AI enabled or AI minded, to be able to do their job, better, faster, smarter. Because this is just not about knowing accounting, but it's also about applying smart technologies related to AI and ML in our day-to-day accounting and finance business. So just kind of reorienting the talent. This is one of my favorite slides. I see that from a finance perspective, there is what we call intelligent analytics, and then there is intelligent insights delivery. And AI and machine learning has a role to play in both. So, what we call intelligent reconciliation using machine learning. Now, I was talking to my, my friend from Deloitte. This is really, audit and reconciliation. I think there are big topics where machines can do a lot of jobs that were actually manually driven, and you can ask machines to learn certain anomalies in the data or in the pattern, and then apply that on the new data, and it can give you results with very high accuracy. The other one, which I see at a lot of my clients, is when you have got reports which are a combination of financial metrics and text. Their CFO report, their analyst reports are called transcripts. Somebody either goes and manually looks at it, analyzes it, or you use a technology called natural language processing, NLP, to extract the keywords and key sentiments. And that way you can analyze many more 10Ks and 10Qs for a lot more firms if you are into that business. Or you can scroll through a lot of financial and non-financial information that is coming using NLP. Now that can be done at industrial scale. One example that I gave is Accenture has about 477,000 people at the last count. So we are one of, like 500,000 people all over the world. We are a consulting firm, so every 15 days, all of us have to file our timesheets. Essentially, every day, how many hours we spent on what work in which city, at which company, at what cost code, and whatnot. We are a traveling company because we go to our clients and work. So we file a lot of expense reports, travel and living expenses. And every time in the past, our controller and finance function, they will take a sample of that data and analyze it, and they figure out that how many people are filing wrong reports, and they'll go and manually verify. Now what AI and machine learning is enabling to do is really run ML algorithm in all 500,000 time reports every 15 days. And it's done in like, few hours. And it tells Sanjay, you charge $100 from coming, from your office to home, while you should not be charging that. And it's not because they are trying to point finger at me, but they're saying, you might have filed that claim in error. Earlier they were doing it on a sample of data. Now they do it all, for all time reports. And that's only possible because of a combination of computational power and the algorithm that you can make that algorithm learn and learn the intelligence of crawling through all the timesheets that have been filed. Just one of the examples that that I really loved, and I just kind of shared with one of my clients, and we actually now helping them now to develop a similar system for their internal reporting. On the other side is just the insights delivery, right? So at times you get your financial reports. These are all numbers and metrics, but how do you really make sense out of it? How do you write a narrative around that? So there is a concept of natural language generation. To take your financial metrics, use NLG and write a complete report, and just distribute that report to your audience, be your clients or internal executives. So, and of course, there are many more examples of how you can use cloud to deliver all these insights on the go, not really kind of being constrained by the location. This chart is kind of particularly interesting. This is something that our team really worked on, is creating two-dimensional. So if you see different tasks based on work complexity and the knowledge complexity. On the left side, the gray boxes are the ones where we see mature solutions coming in, which are AI and ML driven. On the right side are the underdeveloped solutions, but we know at some point of time, your kind of AI discipline will make those solutions more real. So as I mentioned, right, reconciliation is a no-brainer. You can apply AI to make reconciliation smarter. On the other side, Netflix-like personalization of reports, right? So you've got different executives looking at different reports. That you can actually create a Netflix-like personalization. You can build next best action engine and intelligence behind it to make it work. This is another chart. You see the the different activities. So plan, transact, account, control, comply, report, analyze, and advise. These are different functions, from a finance and accounting standpoint. If you see at the bottom, plan, analyze, and advise is something that requires a lot of contextual knowledge. Everything other than that is either digitized or it has a potential of digitization. So you can put a combination of machine learning and robotic process automation, and you can digitize these functions. That means that executives are spending more time on plan, analyze, and advise, which requires contextual knowledge and expert understanding. This also means that there are going to be some impact on the workforce. So if you see on the left side, we talk about for a given function, so say for accountants, 50% of it is done by robots or different AI-driven humanoids or solutions. On the right side is what actually humans, the proportion of work that will be retained by humans. And again, in that, there's also a combination of adaptive workforce and fixed workforce. So workforce which does the same job again and again, and the workforce which actually learns new job for that function. Similarly, say tax examiners and preparers, right? We see that it's going to be heavily impacted. About 60% of the work is going to be mostly driven by humanoids or AI solution, and 40% will be left for humans to do. So you can clearly see that there's going to be a big impact on the workforce and what proportion is going to shift where. I think with that, I kind of I rattled through a lot of different trends and capabilities and technologies and what impact it may have for finance and accounts function. I'm very happy to take any questions if you have.
There's one question.
Yes.
My question is, what thoughts do you have on the academic role of AI and data analytics, or data analytics in the academic arena on the undergraduate versus the graduate degree? Not in computer science, but in accounting.
So I think I probably alluded to, if I'm getting your question right, I alluded to that point that I think in every discipline that we see, we go and talk to our clients. I talk to my clients in banking space. Earlier, either you were an accountant, or you are a marketing professional, or you're a finance professional, or you are like a tech or systems person. Now I think each one of them have to come with additional understanding and knowledge of ability to deal with data, and ability to deal with the data not just in terms of the looking at your balance sheets and income statements and in Excel and accounting packages, for example. It's about, can you really extract all that information, put that into a big data environment, and you can analyze that data smartly through some of the open source algorithms. So essentially, pretty much everybody has to be a little bit of data native, and they should have some level of comfort in dealing with not very heavy duty codes, but some codes, so that they can extract their own information, they can analyze the information, and then so that they are smarter. So they are not doing the things which can be manually, So basically a lot of things which are manually driven today, they can be done smartly through AI and ML, they can handle that. So it's a combination of core knowledge and a little bit of knowledge of data and machine learning. And for you to do machine learning, you don't need to be like a data scientist. Some of these are very standard tools, they are very intuitive, and they just help you do your job smarter.
Thank you.
What do you see as a timeline for this becoming more popular, more getting out there to the market?
Retire soon.
What's interesting is if the students aren't being taught this in college yet, and this is used for like very large companies and large different industries, I mean, where do you think this will be in 5 years?
I would say this is, I'll take my example. When I started my career, I used to be a risk modeler. So I used to model credit card defaults and assign grade scores when you apply for, all that was data driven, analytics driven, but it was not many people knew about it. In last 4 or 5 years, we see a clear uptick in terms of the awareness, but we see that except very large firms, this is not really done very systematically. This is still in the, what we call the proof of concept stage, where you just take one business problem, do in a lab environment in 3 months, show the value, and firms are still trying to get their arms around scaling up these solutions. What we're going to see over next 5 to 10 years is exponential adoption, from basically POCs being industrialized and really made what we call the POCs going enterprise-wide, applicable across the enterprise. What we have seen in last 4 or 5 years, also the exponential increase in the discipline of data science in colleges. If you say 10 years back, if you ask a college, they would not have a special course on data science. Now there hardly be a college which doesn't have a course on data science. So clearly colleges are anticipating the needs of this skill, and I think they are preparing for the massive demand which is going to come.
Yep. I think, why don't we move on to Spencer, just in the interest of time, because I think he's a perfect example of what colleges are investing in,
Yes.
right? Because his career and his major didn't really even exist. Maybe even when you were thinking about going into college, right? Your artificial intelligence, at least the PhD that you're thinking about. So why don't we let Spencer
Yes, that's a
present,
very nice
and then
segue.
we can take some questions after.
Yeah, absolutely.